Introduction to Displacement. Displacement is a fundamental concept in physics that describes the change in position of an object. Whenever an object moves from one place to another, its position relative to a reference point changes. Displacement helps us understand motion more accurately because it considers both the amount of movement and the direction of movement. Definition of displacement. Displacement is defined as the change in position of an object in a particular direction. It is the shortest straight-line distance between the initial position and the final position of the object. Displacement depends only on the starting and ending points of motion and not on the actual path taken. Mathematical expression and unit displacement is mathematically expressed as displacement equals final position initial position. The SI unit of displacement is the meter, m. Since displacement includes direction, it can be positive, negative, or zero depending on the chosen reference direction. Nature of displacement, vector quantity. Displacement is a vector quantity, meaning it has both magnitude and direction. The direction indicates where the object is located relative to its initial position. This vector nature distinguishes displacement from distance, which is a scalar quantity and has only magnitude. Difference between distance and displacement. Distance refers to the total length of the path traveled by an object, while displacement refers to the shortest straight-line distance between the initial and final positions. Distance is always positive and path-dependent, whereas displacement can be positive, negative, or zero, and is path-independent. Special cases of displacement. Zero displacement. Displacement becomes zero when an object returns to its initial position after moving. Even though the object may have traveled a large distance, the initial and final positions are the same, resulting in zero displacement. Example: a runner completing one full lap of a circular track has zero displacement. Displacement equal to distance. When an object moves in a straight line without changing direction, the magnitude of displacement is equal to the distance traveled. In this case, the path followed is the shortest possible path between the start and end points. Displacement in opposite direction. If an object moves in a direction opposite to the chosen reference direction, its displacement is considered negative. Example: if east is taken as the positive direction, motion towards the west will have negative displacement. Maximum and minimum displacement for a given path. The maximum displacement occurs when the initial and final positions are farthest apart. The minimum displacement occurs when the final position is close to or the same as the initial position. Displacement in circular motion. In circular motion, displacement depends only on the angular separation between the starting and ending points. After completing half a circle, displacement is equal to the diameter of the circle. After completing a full circle, displacement becomes zero. Displacement in different dimensions. In one-dimensional motion, displacement occurs along a straight line. In two-dimensional motion, such as projectile motion, displacement has both horizontal and vertical components. In three-dimensional motion, displacement is described using three perpendicular directions and is calculated using vector methods. Importance of displacement in physics. Displacement is essential for defining and calculating physical quantities such as velocity and acceleration. Velocity is the rate of change of displacement with time. Most equations of motion and laws of mechanics are based on displacement rather than distance, making it a core concept in physics and engineering. Real-life applications of displacement. Displacement is widely used in GPS navigation systems to calculate the shortest route between locations. Engineers use displacement to measure deformation in structures like bridges and buildings. In sports and biomechanics, displacement helps analyze movement patterns and performance. Conclusion: displacement